In this chapter, we're going to start talking about estimation and figuring out what we can say about a population based on a sample. And we're going to start with talking about confidence intervals for the population mean in the situation where the population standard deviation is known. And along the way, we'll talk about sample size, how big a sample you need. So at the end of the last video, I left you with a question. How do we know what mu and sigma, that is the population mean and standard deviation, are? In the example we were looking at of the meadow full of flowers, I told you, since I made up the example, I got to just say what those are. But if this were a real-world meadow, the only way to know for sure exactly what those numbers are would be to go out and measure every single flower in the whole meadow, and then use all those measurements and calculate, or put them into a computer and have it calculate, the mean and the standard deviation. But what if we didn't know the population mean, and we didn't want to or couldn't go out and measure every single flower? How could we at least get a good estimate of what the average height of all the flowers in the meadow is, without having to measure every last one? Do you remember way back at the beginning of the course when we talked about populations and samples, and how a sample is a subset of a population that is supposed to be representative of the whole population, so that you look at the sample to try to get some idea of what's going on with the whole population? Like if you had a whole big bathtub full of purple and blue beads, and you wanted to know what percentage of the beads were purple without having to go through and count all the beads. You could get a pretty good idea, a good estimate, by mixing up the beads in the bathtub really well and then pulling out a big handful or cupful and then seeing what percent of those are purple. So that's what we're going to get into in this chapter. Estimating or figuring out something about a population, some big group of people or flowers or beads or whatever, from looking at a sample. So in the flower example, how can we get an estimate for mu? Get a sample of flowers. Go out and just measure a dozen flowers, or 2 dozen, or 100 of them, but not all of the thousands and thousands of flowers that are in the whole meadow. Calculate the mean of your sample. Take those flowers that you measured, those dozen or 100 or however many there are, add those heights together and divide by how many there are. That would be your sample mean, X bar. Then use this to estimate the population mean, the average height of all the flowers in the whole meadow. Now, some questions about what happens when you do this. How do we know how many flowers we need in our sample? Is it enough to just pick a dozen flowers? Do we need 100 or 200? How many flowers do we need to measure? Another question you might ask, how close is that sample mean to the actual population mean? If the flowers in our sample had an average height of, say, 15.2 inches, the population mean ought to be somewhere close to that, but how close? And how sure can we be about that? Now, the first question we'll answer last. Towards the end of this section, we'll talk about how to determine how big a sample you need, how many flowers or people or whatever you need in your sample. But as far as how sure we can be about our estimate, the name for that is the confidence level. So, for example, the most common confidence level is probably 95%. So if we have a 95% confidence level, we can be 90% confident, 95% sure that our estimate contains what it is we're actually estimating, that our estimate is within the degree of accuracy we say it is. And as for what that degree of accuracy is, how close x bar is to mu, that's the margin of error, and it's related to the confidence interval. And I'll be talking about what those are and how you calculate them. Let's suppose you want to know what is the mean weight of all of the pink elephants in the world. Now, assume for the sake of this silly example that there actually are pink elephants in the world. There's lots of them out there in the jungles and forests, and you would not be able to track every single one of them down and weigh them, but you could go out and find some. You could get a sample of pink elephants and weigh the elephants in your sample. But you want to know not just what's true for your sample, but what's true for the whole population, all the pink elephants in the world. So you weigh a sample of 50 pink elephants, and the mean weight of those 50 elephants turns out to be 9,650 pounds. So that would mean that x bar equals 9,650. In that case, if you just had to pick a number, your best guess for mu, the mean weight of all the pink elephants in the whole world, the best number to guess would be 9,650, what you got for your sample mean. Now that is just a guess. You're not saying for sure that the population mean is exactly 9,650 pounds, but it's probably somewhere close to that. It's not exactly that because of sampling error, because the sample is not a perfect representation of the population, but that's the best point estimate. So a point estimate is a single point, a single number that you use to estimate something, in this case, the mean weight of all the pink elephants in the world. But we don't want to say, oh, the mean weight of all pink elephants in the world is 9,650, because that makes it sound like we're more precise and more confident than we really are. But we don't want to say, well, we think it's probably somewhere around 9,650, because that's kind of vague. What do you mean by probably? What do you mean by somewhere around? I mean, it's correct to say that, but it's pretty vague. So to be more specific about what your estimate is, you might be able to say something like, I'm 99% sure that the true population mean weight is within 300 pounds of 9,650. That is, that it's somewhere between 9,350 and 9,950. That's 9,650 plus or minus 300. Or you might say, I'm 90% sure that the true population mean is within 40 pounds of 9,650. So somewhere between 9,650 minus 40 and 9,650 plus 40. Now in these examples, these ranges of values that mu is somewhere within or between are what we call the confidence intervals. So something like saying that mu is between 9,350 and 9,950, or between 9,610 and 9,690. That's a confidence interval for mu. It's an interval that we're saying that mu probably falls somewhere in that interval. And then that number that we say it's within, that's the margin of error. And notice that we've got a smaller margin of error with the 90% confidence level, and a bigger margin of error, a wider interval, with the smaller with the larger confidence level. The more sure you are, or the more sure you have to be, the wider the interval has to be. So the confidence level is the probability, like 90% or 99%, that the confidence interval contains the actual value of what it is you're trying to estimate, in this case mu. the greater the confidence level, the wider the interval has to be. So an example I like to use is, suppose you're one of those carnival guys who guesses people's weight or guesses your age or things like that. So he says, okay, step right up and I will guess your weight. And if I'm wrong, you win a prize. And so you step up and say, okay, try me. How much do I weigh? And he says, well, you weigh somewhere between 50 and 500 pounds. And I am really, really certain about that. I'd bet my life on that estimate. And you'd be like, okay, I'm not all that impressed. I mean, yeah, you're right. I am somewhere between 50 and 500 pounds, but that's such a wide range of weights that anybody could have told you that. Now, if he had said something like, you are somewhere between 144 and 147 pounds, then it would be a lot more impressive if he's right. But on the other hand, he's not as sure that he is right. He said, well, I think you're somewhere between 144 and 147, but I'm not sure. Could be outside that range. I could be wrong about that. So the more you narrow things down, the less confident you are. The greater the confidence level, the wider the interval has to be. The narrower the interval, the smaller the confidence. And the other thing that affects how wide the interval is your sample size. By using a larger sample, you gain greater precision. The more flowers you measure, the better an estimate you can have, and the more sure you can be, and the more you can narrow things down. Okay, so here's the situation. Mu, the population mean, is unknown. And we want to estimate it based on what we know about a sample. We have a certain confidence level in mind, like 99% or 95%, and we want to find the confidence interval that we are that sure, that confident, actually contains mu. Do we know the population standard deviation? Well, in real-world examples, very often we don't, because that's something about the whole population, and if we don't know what the mean of the whole population is, how would we know what the standard deviation of the whole population is? Once in a while we do, but often we don't. And that makes a difference. That changes things a little. For now, we're going to assume that we do know the population standard deviation, just because that makes things a little simpler. But in the next chapter, we'll get into, okay, what do we have to do differently if we don't know the standard deviation for the whole population? We can calculate what it is for our sample based on our sample data, but in that case, we'd have to do something a little different from what we're talking about in this section. So, an example problem would be, suppose we want to know the average weight of all the pink elephants in the world. We get a random sample of 50 elephants, and we find that their mean weight is 9,650 pounds. And suppose in this example that we know that sigma, the population standard deviation, is 110 pounds. What is the 95% confidence interval for the true mean weight, mu, of pink elephants? Now, it turns out that the answer to that question is that mu is between 9,619.5 and 9,680.5. So that is the answer. That is the confidence interval. In the next video, I'll show you how that is calculated, how you come up with those numbers and that interval to answer a question like that.